Okay, so I have only this line must be Kara Carson. Let's wait for a few more minutes. Probably people didn't see my last email since it was sent in the really last moment. I'm sorry for my email being sent so late. So, do you guys have any question before we start? Any comments? Any concern? I actually posted the review sheet on Brightspace for our exam 3. And I posted both copies, the Word and the PDF. And my plan is to give you the exam on section 3.57, 4.1, 2, 3, 4, 5, and 7.1. But if 7.1 seems too overwhelming, then I'll skip that and leave it for the final exam. And also, previously, I was thinking of giving you the exam on Wednesday, but I realized that I actually have to give exam to all of my classes in that week. And I have my own paper due, project due on 7th and 12th. So like, well, let me give the exam on 5th so that I have enough time before our last day of class. So I have 2 weeks to grade them. I can grade them slowly. I don't have to grade them in a rush, and it will be better. So instead of having our exam on May 7th, I decided to give the exam on May 5th. Did you guys notice that I changed the due date? And I updated the new version on Brightspace saying it's updated syllabus. Final exam, we planned to give it on the last day, May 14th, in class. In that way, you don't have to come back for another day. Usually final exam is after the last day, and the time is a little bit off than regular class hour. But for our case, it doesn't matter. We're going to have the same 2 hours anyway. So I'll have it in last class. Review sheet for the final. All you have to do is study the review sheet for exam 1 to 3. And I'll tell you what will be from 7.2. Even though the syllabus has 7.3, but I prefer not to cover it in class. So my plan is to go up to 7.2. And I'm not sure who's going to make the final, the department or me. If I make the final, then I'll make it based on whatever we learned in class. But if the department make the final, then whatever we didn't cover in class, I'll cover that before the final. But most likely I will make the final because every other calculus class they're using a different book than what we are using. So I don't think department will make a final only for you guys. And I hope I make the final. If I make the final, I'll make it very easy. I mean, not very easy, but easier than the departmental final. Uh, um, our last day of class is 15, but 15 is a Thursday, so for us it should be 14. And if we have the final exam on 14th, that means we have one class to cover 7.2 and one class to have a review. So today is 21. We have 1, 2, 3, 4 classes, and we have 4 sections, right? Today we're going to do, oh, we have 3 sections. Oh, not bad. So we have 4.4, 5, and 7.1. 3 sections to cover before our next exam. So if you can do 3 days, 3 sections, then on 30th, we can have a review. And on 5th, we can have our exam 3. Any question? Comments? Anything? Okay, so it's 38. Let's wait 2 more minutes. Who is not here? Ellen. Apollo is here. Jocelyn, Kimberly, Judith. So Judith, Ellen. Who else? We have Mac, Lucas, Andy. So Nicholas. Nicholas is also not here yet. And who else? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay. Any question from you guys? Any comments? Concern? Complain? Nothing. Okay. Oh, about the review sheet. So for 3.5 and 7, I don't have the answers because all of them we did in class. So you can simply watch the recording or your class notes. But do you have the same question twice? Is C for the first derivative and D for the second derivative? Yeah. For some reason, I have the same things twice. So ignore that. For 4.1 and 2, I didn't go over them in class. Instead, I gave you a asynchronous course. So for these questions, I have the answers next to the question. From 4.1, all you have to worry about is left-sided and right-sided estimation. And I believe in your recording, what I told you to watch, have this described very well. This question 2 is optional. It's a very interesting question, and it's also important for calculus students. But for you guys, it's optional. If you like it, you can do it. If you don't like it, you can ignore it. 4.2 is interesting, even though we did not go over directly these questions, but these are just like 4.3. Plus, most of them are based on rules. So I'm going to share the rules again today. If you compare the rules with the questions, you can do them easily. Also, I'm going to go over them on the review day. 4.3, we did it in our last class. It's evaluating the definite integral. So first we find the antiderivative, and then we substitute the variable with the limits. And also, I want to add these questions in class, if I'm not wrong. Today we're going to do 4.4. It's a very fun section. So from here, I'll ask this type of question. 4.5 is also fun, very fun. It's substitution rule for antiderivative. 7.1 is not bad, but it's kind of more work than 4.4 or 4.5. Okay, then let's start. We are starting 4.4. Previously, we did 4.3, where we learned how to evaluate definite integral. And today, we are going to learn about the fundamental theorem of calculus. The fundamental theorem of calculus is appropriately named because it establishes a connection between the two branches of calculus, differential calculus with the integral calculus. Differential calculus arose from the tangent problem, whereas the integral calculus arose from seemingly unrelated problem, the area problem. So basically here they're saying that derivative and antiderivative, how they're connected. Newton's mentor at Cambridge, Isaac Barrow, discovered that these two problems are actually closely related. In fact, he realized that differentiation and integration are inverse processes. It means derivative, the inverse of the derivative is antiderivative. Same thing, the inverse of the antiderivative is derivative. So they are inverse of one another. The fundamental theorem of calculus gives the precise inverse relationship between the derivative and the integral. It was Newton and Leibniz who exploited this relationship and used it to develop calculus into a systematic mathematical method. Now, what is the fundamental theorem of calculus? Fundamental theorem of calculus has two parts. We are going to discuss only part 1. We are leaving part 2 for calculus 2. So in this theorem, it says, if f is continuous on a closed interval ab, and let's say g of x is the antiderivative function from a to x, then the derivative of this function is the original function f of x. The second part says the antiderivative of f of x is big F of b minus big F of a, where the big F is the function of the antiderivative of small f. So the derivative of the big F will be the small f. So what does that mean? In simpler word, it means if you have an antiderivative function that runs from a to x, and our function is f of t, and we are doing the antiderivative respect to t. So let's say you have a function, something like this, and our antiderivative is running from a to x. So it's the area here. So they're saying that if f of t is a function that represents the antiderivative, and let's say we give the name of this function as g of x, then if you take the derivative on both sides, let me erase this. If you take the derivative on both sides, then the derivative and antiderivative cancel out, and you get this original function back. The interesting thing is, when you get the original function back, you have your x as input instead of, okay? So instead of t, we get f of x back. In simpler word, it means derivative of the antiderivative is the original function. That's it. This is what it means. Now you may wonder, how is this happening? Well, we can remember this easily, or you can understand this easily if you go back to the evolution theorem we talked about in section 4.3. In our last class, we talked about evolution theorem, where it says antiderivative of a function from a to b is big f of b minus big f of a, where our antiderivative of f represent the big f function. Now, instead of a to b, if you have your limits from a to any x value, that means this definition becomes f of x minus f of a. So f of x, we don't know what that is because it's a function. So this is a function. On the other hand, f of a is a constant because we're evaluating our function when x is a. So f of a is constant, but f of x is a function. Now, if you take the derivative of this on both sides, we get derivative of the antiderivative equals to big derivative of the big f of x minus derivative of the big f of a. Now, since f of a is constant, so obviously its derivative has to be 0 because derivative of any constant is 0. And derivative of the big F, we already know that from our last class, that if you take the derivative on both sides, we get derivative of f is the small f because derivative and antiderivative cancel out. So derivative of the big f of x is simply the small f of x. So the left side gives us the right side. And all we did here is we applied the knowledge we learned from the evolution theorem, as well as the concept is that derivative of small f is the big F. Okay? By applying these two, we can see that, well, the left side is equals to right side. Now, how do you use that to do any example? For example, let's say you're finding the derivative of the antiderivative of the function square root of t squared plus 4. Sorry, my dt should be inside here. Let me fix it. Oops. Okay, so if you're given the function square root of t squared plus 4, and you're taking the antiderivative of this from 0 to x, and then you want to know what's the derivative of this antiderivative, we can use whatever they showed us in the left page. We can use the fact that this function inside, let's say this function inside is f of t. If this is f of t, we know from before that antiderivative of small f is big F. This is the notation we used before. And we also know that derivative of the big F is the small f. So we are assuming one thing, and we are using the knowledge of two things from before. then this thing here becomes derivative of antiderivative from 0 to x f of t dt. Now this thing here, again, my place dt is on the wrong place, so I put it here. So antiderivative of the small f is big F. We know that. That means here. Oh, what happened? Okay. This antiderivative is big F, and we are evaluating that into t equals 0 and t equals x. So this inside here becomes f of x minus f of 0. And then you're taking the derivative of the inside. Now derivative is distributable, so we distribute the derivative into both of them. So we get derivative of the big F of x minus derivative of the small f of 0. Sorry, derivative of the big F of 0. Now, as we know, f of 0 is always a constant. Whenever you substitute x with a number, the outcome always becomes a number. So f of 0 is a constant, so when you take the derivative constant, it becomes 0. So this thing becomes 0. And derivative of the big F, as we know, is the small f. So a small f of x. But what is small f of x? If f of t is square root of t squared plus 4, that means f of x must be square root of x squared plus 4. So this f of x is nothing but this function. Now, if you think all of this seems complicated, don't worry about that. All you have to do is replace your variable in the given function, what you're given the antiderivative of. Replace that variable with the function you have in the limiting value. So we have limiting value x here. All you have to do is replace your variable in the given function with that x, and then at the end, once you replace, you multiply by the derivative of the given function. So let's say you have like 0 to x squared of square root of, let's say, t. Now let's say cube root of t dt. Now what is the derivative d dx of this? Is you replace your variable t with the x squared. So you get cube root of x squared, and then you multiply by the derivative of your function, which is 2x. This is your answer. Also, you have to keep in mind that we have a rule which you learned before. Oh man, I forgot to. Oh, never mind. We do this when our lower limit is a number. Okay, so when the lower limit is a number, for the upper limit, when the lower limit is a number and the upper limit is a function, we simply ignore that lower limit and we replace our variable in the function with the upper limit, multiply by the derivative of the upper limit. But if you have the position switched, like your number is on the upper limit and your function is on the lower limit, then all you have to do is change the sign. We learned it before, I think, but let me refresh your memory again. If you have a to b of f of t dt, this is same as negative b to a of f of t dt. So we can switch our limits but as a result, the sign gets negative. Why that is because when you have a function and you have a to b, it means it's the area under the curve above the x-axis is positive. Now, when you switch the limit, it means you are changing your area from the upper side to the lower side. So basically, you're saying that this is your area. So this area is negative. When you switch the limit, you switch the area. So it becomes negative. Now let's do one more example. Let's say we are given that g of x is the antiderivative of the function t to the power 4 within the limit 1 to x. Now we want to know what is the derivative of this antiderivative. Well, by the fundamental theorem of calculus, all you have to do is replace your variable in the antiderivative function with your upper limit function. Because when you substitute the lower limit, it becomes 0 anyway. See here, when you substitute a number, the whole thing becomes 0, and the function becomes a number, and the derivative of the number is 0. So that's why we ignore the lower limit, because that gives us a 0 anyway when you take the derivative. So we only substitute the upper limit, which is a function, and then we multiply by the derivative of the upper limit function, which is 1. So in this case, the result is x to the 4. Any questions so far? Are any of you feeling lost already? No? Okay. Let me erase this and do it together. So observe here. Our number is the upper limit and variable is, the function is the lower limit. So their position switched. We don't want that. We want our upper limit to be the function. So first step is rewrite your limits. We write 7x squared of square root of 5 plus r cubed dr. But since we switched our limit, as a result, the area becomes negative. And now all you have to do is replace this r with x squared and then multiply by the derivative of the x squared. So when you do the derivative of the g function, it's same as square root of 5 plus, we are given r cubed, but instead of r cubed, we are going to write x squared cubed and then multiply by the derivative of the x squared, which is 2x. So if you write it a little bit nicely, you get x to the 6 under the square root and then 2x. Or usually we write the derivative in the front, 2x and then square root of this thing. What happened to dr? When you take the antiderivative, so when you take the derivative of the antiderivative vanishes. So if you have f of t dt as the antiderivative function, then when you take the derivative of that, this derivative cancels with the antiderivative. Now, antiderivative is this thing, okay? This is the antiderivative. So we only look at the variable in the function, the antiderivative sign and d, whatever we have, dt, dr, dz, dv, whatever we have, they're connected, they're combined The combination of them gives us the antiderivative notation. So anytime we take the derivative, they cancel the sign as well as the d thingy. Clear? Any question? Okay, so I went over this in our last class, but let me refresh your memory again. When you take the antiderivative of a constant, and you're taking the definite integral. Okay, so definite integral. Definite integral means you have the two limits. Any two limits, okay? And do something. As long as your limits are given, we call them definite. Definite means they are not unlimited. They're limited. They're in a box. So antiderivative of a constant is constant times the difference of the limit, b minus a. And then antiderivative of the sum of function is antiderivative of the individual function. Then antiderivative of a to b of a constant time a function, you can pull out the constant and then take the antiderivative of the function. Antiderivative, the difference of the function is difference of the individual antiderivative. Now, if you have your interval into three parts, A, B, C, then antiderivative from A to C, okay, A, C, B. Then if you have two intervals, three limits, then antiderivative from A to C plus antiderivative of C to B is same as the antiderivative from A to B. In other words, they're saying that whatever area we have from A to C, if you add the area from C to B, this is same as the total area from A to B. And it's true, right? If you look at the picture, it makes sense. The next one is what I showed you just now. You can switch your limit, but as a result, your area becomes negative. And finally, at the end, it's if you're taking the antiderivative from A to A, see, from A to A, there is no area under your function. There is no area. So area is 0 because you don't have an interval to have your area. You have only a point, this point. It doesn't have any area. So if your limits are same, it means it's just a point. It doesn't have any area. So area is 0. Now let's do something a little bit different. It says find the derivative of this antiderivative function. And this antiderivative is running from sine of x to cosine of x. Well, this is an unusual function. I mean, the function is usual, sorry, my bad. The interval given to us is unusual. In order to use fundamental theory of calculus, we want at least one limit to be a constant, a number. But here we have both function. So that's why in order to use the fundamental theory of calculus, first we need to split them into two pieces. In the first piece, we are going to write sine of x to 0. In the second piece, from 0 to cosine of x. And you're allowed to do so, because see here, if this is sine of x and this is cosine of x, then we can break it down into two pieces, sine to 0 and 0 to cosine. of the same function. 1 plus v to the 5 whole thing to the 8 dv. 1 plus v to the 5 whole thing to the 8 dv. So I splitted our one big interval into two pieces. Now this piece is okay because our 0 is on the lower limit. But this piece is not okay because our lower limit is not 0, it's not a constant, it's the function. So we need to switch them. We are allowed to switch them, but as a result, we are going to have a negative area. So this is same as 0 to sine of x of this function. 1 plus v to the 5 to the 8 dv. And since the second interval is okay, so we're going to keep this 0 to cosine of x, 1 plus b to the 5 whole thing to the 8 dv. Now this is our y. They want us to take the derivative of the y. Derivative of the y means all you have to do is replace this variable with the upper limit and then multiply by the derivative of the upper limit. Same thing here. We are going to replace this variable with the upper limit and then multiply by the derivative of the upper limit. So we get negative 1 plus this thingy 8. But instead of writing v to the 5, we are going to write, it is too small, let me make it a little bit bigger. Sine of x to the 5. And then multiply by the derivative of the upper limit. Now, what's the derivative of the upper limit? What's the derivative of the sine? Do you guys remember? Derivative of the sine is? Do you remember, guys? What's the derivative of the sine? Good job, cosine. So once you, so this actually has a name. It's called reverse chain rule or something. So this is a reverse chain rule or something like that. I forgot the name correctly. We replace the function and then we multiply with the derivative. So the first part is over. We do the same thing on the second part. We have 1 plus v to the 5 to the 8, but instead of v, we write cosine of x. And then we multiply by the derivative of the cosine. Now, what's the derivative of the cosine? Negative sign. Good. So I do negative sine of x. So if you write it nicely, then this thing becomes negative cosine of x 1 plus sine to the 5x to the power 8 minus sine x times 1 plus cosine to the 5x to the 8. So this is the final answer. And what I did here is this. Cosine x to the 5 is same as cosine 5 to the x. We are allowed to put this power inside the trig function. Same thing, sine x whole thing to the 5 is same as sine 5, sine to the power 5 whole thing of x. Any question? Any comments, concern? Okay, so since I was hoping to have in-person class, so I have these ready for you guys. And I wanted to work in a group, but since it's online, try them on your own, but you can have a conversation with your neighbor. I mean, sorry, you don't have a neighbor today, with your classmates online. You can write on the chat box, you can unmute yourself, or you can unmute yourself and talk on the microphone. So I have 1, 2, 3, 4, and then one more. Okay, so I'll give you till 6:30. Try as much as you can until 6:30. Okay? And once you are done, you can write the answer on the chat box. Or if you need any help, you can talk to your peers, or you can ask me. Or let me actually do one more with you guys. A, because I did not show you what happens when you have a fraction. So let's do A together. And then you're going to do everything by yourself. So in here, oh, it's not a problem, never mind. Since you're taking the derivative, so it's fine. In 4.5, you're going to take the antiderivative, the actual antiderivative. Then we need to do something. So I'll do that later. Go ahead, try this. Let me stop recording so that the time doesn't get wasted. If I forget, remind me to turn on recording, okay? When you're back. Pause recording. Okay. First question. The g function is the antiderivative. They're asking what is g prime. For g prime, all you have to do is replace this t with the function and then you multiply by the derivative. So it's 3 over t cubed plus 7. Instead of t cubed, it becomes x cubed plus 7. And then you multiply by the derivative, which is 1. In other words, this is simply 3 over x cubed plus 7. That's it. So derivative of the antiderivative is the original function. And that was the original function. The next one has a problem. Our lower limit is not the number, it's the function. So we need to switch. But when we switch, our area becomes negative. So we get y equals negative 8 to tangent x 5t plus square root of t dt. So here we have variable twice in our function. One is here, one is there. So we're going to replace both of them by this tangent x. So the y prime is negative 5 tangent x plus square root of tangent x. And then we have to multiply by the derivative of the tangent. Do you guys remember what's the derivative of tangent? Derivative of the tangent is secant square. Good job. So we are done, but people usually write the derivative in the front. So negative secant square x, and then 5 tangent x plus square root of tangent x. Any question? Was anything unclear? No? Okay, the next one. Same issue. Our lower limit is not the number, so we need to switch. As a result, we get a negative area. So negative of the antiderivative runs from 1 to 2x to the 5, and our function is t cubed plus 15. Here we have only one variable, t, so we are going to replace that with the upper limit. So derivative of x, so f of x is 15 over t cubed plus 15, but the t cubed becomes 2x to the 5 whole thing cubed. And then we need to multiply by the derivative of 2x to the 5. Now, what's the derivative of 2x to the 5? 10x to the 4. Great. So technically we are done, but just to make it look nicer, we write one more line. Derivative of f of x is negative. We multiply 15 and 10x, so 150x to the 4 over 2. Since we have two parts together, so I multiply them. So here we multiplied these 3. We got 150x to the 4. And the denominator, sorry, this is 2 to the 3 and x to the 5 to the 3. So 2 to the 3 gives us 8. X to the 5 to the 3 gives us 15 power. And then we have plus 15. Let me write my 4 inside. Question. Oh, and then we can reduce. We can reduce 8 and 150. 8 goes to 15 once. And then we have 70. So it doesn't go to 150 evenly. Let me see. 150 divided by 8. Now, 150 divided by 4. No. 150 divided by 2, 75. So the both are divisible by 2, so we get 4 here and 75 here. So this becomes negative 75x to the 4 over 4x to the 15 plus 15. Question? All of these are from your homework, okay? I'm helping you with your homework. I believe Lumen wants you to reduce your fraction, but probably it will also accept the unreduced form. I'm not too sure. But if you reduce, you get 75/4. If you don't reduce, you get 150/8. And then comes the interesting question. So this question is based on the definition. Not the definition, the relationship. So if you have a function, first derivative, and you take the entire derivative of that, the entire derivative as the derivative cancel out, you get h. Now if you have a definite integral, it happens the same thing. The entire derivative and derivative cancel out, you get the original function, but then since it's definite integral, so you're going to evaluate your function with b and a. Now here we don't have first derivative, we have second derivative. So they give you the second derivative and they want you to take the definite integral from 1 to 5. Now, because of this antiderivative, one of the derivative cancel out. So this derivative, antiderivative, and this derivative cancel out. You get h prime, and since this is definite, so you have to evaluate that from 1 to 5. So basically, it's derivative at 5 minus the derivative at 1. Now, first derivative at 5 is 7, and first derivative at 1 is 2. So 7 minus 2 gives us the area of 5. Any question? Any question, comments, anything? Nothing? Okay then. The next one is the direct area problem. So it says the g of x is the antiderivative where f is the function in the graph. So the f is given and the g function is the antiderivative of this function. Now they want us to find what is the antiderivative at 0, at 1, 2, 3, and 6. Now since they didn't give us any function for this question, instead they give us the graph of the function, so we can use the area concept. If you observe, our graph is starting from 0, ends at 7. Okay? So, our g of x, the lowest it can go is 0. The highest it can go is 7. Now in A, they're saying that this upper value is 0. Okay? Sorry, my bad. I should write down the formula first. G of x is 0 to x f of t dt. In A, they're asking g of 0. It means this 0 will be here. So it's from 0 to 0 of f of t dt. It means how much area you have under this graph from 0 to 0. Now, if you observe the rules I showed at the beginning, the area, if you don't have your interval as an interval, just a point, area is 0. So in here, we don't have an interval. We have the same point. We have only one point. So from 0 to 0, it's not an interval, it's a point. So our area is 0. We don't have any area here. Here. From 0 to 0 means this thing. It doesn't have any area. Now B says g of 1. It means from 0 to 1 of the function f of t dt. Now 1 is here. Now 0 to 1 gives us this rectangle. Now this rectangle has an area. It's a rectangle, right? So its area is length times width. Its width is 1 unit. Its length is 2 units. So this area is 2 times 1, which is 2. Not B, sorry. The next one says find g of 2. Now g of 2, let me change the color to blue, is from here to here. So we have 0 to 2 of f of t dt. And if you look at, this is same as we have 2 units here, and then here, and then here. So 1 unit here, 1 unit here, 2 units here, and another 2 units there. Okay, so this much is our area. Now if you want to find the area here, you can easily see that this is 2 by 2. So 2 by 2 gives us 2 times 2 area, plus this one is a rectangle, sorry, triangle. It's 1/2 base times height. So 1/2, our base is 1 unit, and our height is 2 units. 1 unit here and 1 unit there. So we have 4 plus the 2 and 2 cancel out. We get 1. That gives us 5. Any question, guys? Do you guys understand what I'm doing? Yeah. Okay, great. If you don't understand, let me know. Thank you for responding. The next one is asking for 3 and 6. So g of 3 means we are running from 0 to 3 of f of t dt. Now 0 to 3, 3 is here. Let me change the color to blue, this blue. So from here to here is 0 to 3. So this is same as we have 0 to 2 plus this tiny bit. So you already know it's 0 to 2. So this is same as from 0 to 2, and then from 2 to 3. We already know 0 to 2 here is 5 units because you already calculated that. That means the only thing we need to know is how much is the area from 2 to 3. Now 2 to 3 is this part, this tiny bit, which is a triangle. This triangle has base 1 and our height is 3. So it's 1/2 base 1, height is 3. So we get 5 plus 3/2, which is 5 plus 1.5. So that gives us 6.5. Now lastly, g of 6. It means we are running from 0 to 6 of this function, f of t dt. Now we already know that 0 to 3 is 6.5. So we can actually break this down from 0 to 3, f of t dt, and then from 3 to 6, f of t dt. So let me change the color to something purple. 3 to 6, f of t dt. So we already know this is 6.5. So this is 6.5. The only thing we need to know is how much is from 3 to 6. Now 3 to 6 is the area here, this area. So if you observe, this area has a rectangle and a triangle. So from here to here is the rectangle, length is 2 and width is 1. So this tiny piece is 1 times 2. And let me change this color to black. No, not black. Orange. So this piece is a triangle. This triangle has a base 2 and height 2. So it's 1/2 of 2 times 2. So we have a rectangle 1/2 and a triangle 1/2 base times height. So these two cancel out and we get 6.5 plus 2 plus 2. 6.5, 2 and 2. So we get 6, 7, 8 total. Oh, my bad. This area is positive because it's lying above the x-axis. However, this area is negative because it's lying below the x-axis. So we have to subtract the area below the x-axis. So this is 6.5 minus 2 plus 2. So it's 6.5, but how come it's not 6.5? 1, 2, 3, 4. Oh, it's 4/2. Oh man, my bad. This triangle here has 1, 2, 3, 4 height. So it's 1/2 times 1 times 4. Man, Ellen, you could have fixed me. We have 5 plus 2, 7. So this is 7. So we have 7 minus 4. That gives us 3. So this is 7. Okay? So anytime we have area above the x-axis, it's positive, and the area below the x-axis, it's negative. And if you're combining them, you have to subtract the negative area from the positive area. This is called the net area. What is, because you're not taking the derivative, we are taking the antiderivative. The question, the difference between this question and the previous questions, in the previous questions, all of them we took the derivative. Find the derivative of this antiderivative. See, find the derivative. But this question is not asking for derivative. It's asking for evaluate your antiderivative. Means find the area under the curve. Okay. What is about the total area? They're not asking for total area, but they're asking for all the area from 0 to 6. But if you're looking for the total area, then you also need to find this small area here and then subtract that from 7. Thank you, Ellen, for answering that. The next question is asking why this interval is increasing. Now, interval increases where you have positive area. So basically, they're asking which part of this function is lying above the x-axis. This is what it means. Which part of f is lying above x-axis? So the area lying above the x-axis is from 0 to 3. The answer for B is 0 to 3. This is the positive area. Now C is asking, then where this antiderivative has the highest value, the maximum value. Now think about it. Before, so from 0 to 3, so we have 0, 3, and 7. From 0 to 3, the function is increasing. Okay? And then from 3 to 7, the area is lying below the x-axis, means the function is decreasing. So where do you see the maximum of this antiderivative function? It's at 3, right? Where they're changing their sign from positive to negative. The answer for this one is 3. Did you guys understand what I did for B and C? Or do you need more explanation? If you need more explanation, don't hesitate to ask me. Question? No question? Come on, guys, say something. Did you guys understand or did not understand? What? These are from your homework, okay? So in the homework, you have to do this type of question. So Jocelyn understood. Good. Anyone else who does, anybody who doesn't understand, who did not understand, sorry, my bad, and need more explanation? No? No question? Okay. I will post the recording on YouTube. And I'll post the lecture note without the answers on Brightspace. Okay? And this is the picture of the antiderivative function. In your homework, they will ask for the graph. So the antiderivative function from 1 to 3. From 0 to 3, it's above the x-axis, means the function is increasing. And then from 3 to 7, the function was below the x-axis. That means it's decreasing. So it's an upside down parabola where we have the maximum at 3. That's why we have the maximum value at x equals 3. But they're asking for the where, means the x value, not how much. Question? No question? Okay, then let me stop here. Even though it's 7, you still have 20 more minutes. But it's a good place to stop. In our next class, we are going to do substitution rule, which is very fun. So substitution rule 4.5, we are going to do that in our next class. If you want to read ahead, go ahead, feel free to read ahead. And don't forget to do the homework on 4.4. This is 4.4. We already completed everything on 4.4. And I try to do many questions from the homework. So when you do the homework, make sure you have your lecture notes in front of you. All you have to do is connect the lecture notes with the homework question, and then it will be easier for you to complete them. Okay then? Bye for now. And I will let you know on Tuesday night whether my foot is better or not, like I can walk or not, and we can have in-person class, or I have to have another online class. I'll let you know on Tuesday, hopefully Tuesday. Okay. Okay. Bye everyone. Thank you so much for being here. Thank you. Thank you so much, everyone. You too. See you all Wednesday. Thank you, Ellen and everyone.